All right. Okay. So I've shared the screen. I hope everyone is able to see the screen. Right. So basically we have two questions here. This is the first question. This is basically from this paper, test paper 1 from 2020, and it's the May-June exam, right? Okay. So let's talk about the question and then we'll discuss everything. So the statement says the equation of a curve y equals 2x squared plus kx plus k minus 1, where k is a constant. So this is a quadratic curve. That's obvious because the power of x is 2. Given that the line y equals 2x plus 3 is a tangent to the curve, find the value of k. Okay, so we know these type of questions. Now the condition is given. What is the condition? Here is the condition that this line is tangent to this curve. This is what we know now. Okay, this is known. And you need to find the value of k. So this is something we have done very, very recently. We know that we had three cases. In case of a line and curve, it could be that the line intersects the curve at 2 points. So there the discriminant used to be greater than 0. It could be that the line and the curve are intersecting at 1 point only. And when we say that the line is intersecting at 1 point only, we basically call it that the line is tangent to the curve. So there the discriminant used to be equal to 0. And in cases where we had no points of intersection, the discriminant used to be less than 0. So these were the three cases. Now, this is the scenario. We know that it is tangent. So I am going to write it down this way, that the discriminant b squared minus 4ac would be equal to 0. Now, step 1 is to find the quadratic equation related to this context, right? We know that for such cases, we had to make the quadratic equation by equating both the equations, by equating this curve and equating this line. So it would become 2x squared plus kx plus k minus 1 equals 2x plus 3. I've equated the curve and the line because both of them are y equals something and y equals something. So y is equal to y. I've equated that and now I am going to simplify it. Okay. So this can be written as 2x squared plus kx minus 2x plus k minus 1, and then I'll take this 3, so it would become minus 3 equals 0. And now I am going to simplify this, so it would give me 2x squared plus k minus 2, I've taken x common, plus k minus 4 equals 0. Now this is the quadratic equation I would be focusing on, and this is the equation I made using the given condition. So here this is A, this is B, and then this is C. Okay, I'm done with everything. I'm only supposed to plug in ABC in equation number 1, which I made using the given condition. So again, it is b squared minus 4ac equals 0. B is k minus 2 squared minus 4 into a, that is 2, and then into c, that is k minus 4 equals 0. The question was about finding the value of k. Now you can clearly see by making the quadratic equation and by using the equation b squared minus 4ac, I got equation number 2 that is just with k. So k is the only unknown variable in this equation, and I know how to find the value of k very, very easily. Okay, so let's just find the value of k. Then I can write it as k minus 2 whole squared minus 8 k minus 4 equals 0. I will expand it over here. I will open this thing and it would become k squared minus 4k plus 4 minus 8 into k would give me minus 8k, and then plus 32 equals 0. All right, and then I am going to have k squared minus 12k plus 36 equals 0. Okay, so this is a quadratic equation. Now you need to just factorize it. The two factors are very obvious. It's 6 and 6. When you will multiply 6 and 6, it would give you 36. When you will add it, it would give you minus 12. So I can write it as k squared minus 6k plus 36 equals 0. And then I can take k common. So k minus 6, then minus 6, and then it would give me k minus 6 equals 0. And finally, I would get k minus 6 whole squared equals 0 because both the factors are k minus 6. And this would give me k equals 6. So this is going to be the answer. Okay, so I'll explain it again, and then if you have any queries, you can ask me, right? But first of all, I would like to talk about this very interesting thing that the examiner is, he would be giving you some hints. The questions we discussed in during the lectures clearly had, the word values here at times, then set of values. So when it would be set of values, you would know that this would not be an equation, it would be an inequality. Only then you would find a set, right? In cases where we had values, meant that you would be getting two values of k, and now it's clearly mentioned value, so it means that you would be having one value of k, and that is what we got as well. Okay, so this is something I wanted to mention. This would be a great help for you to know if you are going in the right direction or not. All right, okay, so these questions are basically going to be of a specific type. I'm going to explain it one last time, and if you have any questions, then you can ask me. Okay, so what is happening over here? Equation of a curve would be given, equation of a line would be given, and then there would be a condition given. For example, we will be talking about more questions, so you will see the condition could be that the line is intersecting the curve at 2 points. So there the discriminant b squared minus 4ac would be greater than 0. It could be that the line is intersecting the curve at 1 point only, or an equivalent statement of the same case would be that the line is tangent to the curve. It would mean that the discriminant is equal to 0, and if this would be given that the line and the curve are not intersecting at any point, so there b squared minus 4ac, that is the discriminant, would be less than 0. These are the three cases. Okay, now first of all, we are going to make our quadratic equation by equating the curve and the line. So this is the curve, this is the line. I've equated them, I've simplified them, and this is what I got. Okay, step 2, follow the condition. The condition is that the line is tangent to the curve, means that the discriminant would be equal to 0. So b squared minus 4ac would be equal to 0. I need to find out b, that is the coefficient of x, a, that is the coefficient of x squared, and c, that is the constant term, that is k minus 4. After plugging in b, a, and c, this is what I got. And after simplifying it, I got this quadratic equation. Now, all of us know how to solve a quadratic equation. We have three methods. The simplest is to factorize, if that is possible. We factorized, and the two factors were same. We got k minus 6 and k minus 6. So this would give you k equals 6, and this was the answer. Again, the question clearly had find the value of k. So that clearly means you would be having one value, right? So this is the correct answer. Okay, now please ask me if you have questions.
No, it's everything clear.
Okay, and what about Ahmed and Mustafa?
It's clear.
Okay, and Mustafa, are you okay with this? Yes, is it understood? Okay, all right, okay. Okay, great. So let's talk about the next part of the same question. Okay, we are done with the first part. Let's talk about the second part now. It is now given that k is equal to 2. Okay, so where exactly was k? This is k. I'll write down the equation again. This is the curve with k. It is 2x squared plus kx plus k minus 1. So it is y equals 2x squared plus kx plus k minus 1. Okay, this was the quadratic equation given, and it was in terms of k. That again was a constant. Now it is given that k is 2, so it would become, I'll be writing it with the red color again. It would become y equals 2x squared plus 2x plus 2 minus 1. All right. And I can simplify it and write it as y equals 2x squared plus 2x plus 1. Okay, what is the question? Express the equation of the curve in this form where a and b are constants and hence state the coordinates of the vertex of the curve. Okay, we will talk about this part later. For now, you guys need to do the second part. Okay, express the equation of the curve in this form. After plugging in k equals 2, this is what I would get. This is the quadratic equation, and you know how to convert a quadratic equation into this form. So basically we need to use the completing square method here. Okay, please try doing it. I'll give you 3 minutes and then we will discuss it together. But before that, do it and just send me the values of a and b. Okay, it's completely fine if you're getting the wrong answers. That does not matter at all. The only thing that matters at this point is your practice. Just try doing it. All right, I just got one answer so far. I'm waiting for two more answers. It's completely fine if the answers are wrong. I would not say anything. I would not even mention your name. I just want all of you to participate. Please try converting equation 1 to the given type of the equation by completing square method. Okay, just try doing it. All right, okay, let's discuss this question then. So the second part of the question was that now it is given that case 2, when case 2, this curve would become this, and you need to convert this equation to this form. How do we do that? Okay, now one thing is very obvious. Whenever the question is about converting a quadratic equation to this form, always remember we will be applying the completing square method. Okay, let's do that. It's very easy. Okay, so first of all, I will write down the equation again. It is one second. It is y equals 2x squared plus 2x plus 1. This is the given equation, which I need to convert to this type. Okay, then y equals, now I need to apply the completing square method. So step 1 is I need to separate x squared. That is, the coefficient of x squared must be 1. At the moment it is 2. So I will take 2 common and I would get x squared plus x plus 1 by 2. Okay, this is going to be my equation now. Okay, number 2. Step 1 was to take the number here common, just so the coefficient of x squared becomes 1. Step 2, just follow the coefficient of x, that is 1 for this case, and I'll write it down as x, and then I need to add half of this number, square that, and then subtract half of this number, and then I'll be squaring it, and then plus 1 by 2. We are almost done. Please pay attention. It's easy. It's not difficult. I'll explain again. Then this would give you y equals 2 common x plus 1 by 2 whole squared. I'll just use square brackets here. And then this would become minus 1 by 4 and then plus 1 by 2. And you are going to get y equals 2 multiplied by x plus 1 by 2 whole squared, and then 1 by 2 minus 1 by 4 is going to give you what? We have 0.5 minus 0.25, so it would give you 1 by 4. Okay, this would give you 1 by 4, and when you will multiply this 1 by 2 with this term, it would become half. So this is 2 into x plus 1 by 2 squared plus 1 by 2. This means this is your A and this is your B. Okay, I'll explain it again for those who joined late, like as in they joined session a bit late. That is why they were not able to understand, because otherwise we have discussed this clearly. Okay, but it's fine. Acha. The good thing is that we have a fixed number of steps, and the question is going to be of a certain type, so you would be able to do it. This was the equation we had in question, and now we are told that k is equal to k is equal to 2. So after plugging in k equals 2, this was my quadratic equation. Okay, so I have clearly an equation that is quadratic, and I need to convert it to another type. Let's see how to do that. Okay, please be careful and just know that this type would basically come by completing square method. Completing square method would be used here. Okay, so this was my equation. Step number 1 is basically to have the coefficient of x squared as 1. For now, the coefficient of x squared is 2. I've taken 2 common, and now the coefficient of x squared is 1. So this is going to be step number 1. Okay, step number 2. Just follow the coefficient of x. This is the coefficient of x, it is 1. Half the coefficient of x, it would become 1 by 2. Now you need to add and subtract the square of 1 by 2. Okay, this is what we did. Finally, you know, x squared plus x plus 1 by 2 whole squared is basically x plus 1 by 2 squared. and this would give you minus 1 by 4 plus 1 by 2. This 2 was written outside, it would be multiplied with this term, you would get this, and again it would be multiplied with this term. This would become 1 by 4, 1 by 4 multiplied by 2 would give you 1 by 2, and this is going to be the answer. Now A is 1 by 2 and B is 1 by 2, right? It's very obvious. Now, please tell me if you were not able to understand this. Yes. Ahmed, please tell me if you're okay with this or not.
It's clear, ma'am.
Okay, and what about Motasim? Are you good with this?
Yes.
Okay, all right. Okay, I hope that if you are saying it's good, so it's good. All right. The next part of the question was, and hence state the coordinates of the vertex of the curve. Okay. Now we know how to find the coordinates of the vertex through a long method, right? If the examiner is saying, and hence state, it means that the values are obvious and you're just supposed to state them. So this is something we did not discuss in the class, but I'll tell you here, okay? Whenever you have a quadratic curve, you know how to find the vertex, right? First of all, we need to find the x-intercepts. Then we need to find out the middle value of the x-intercepts. That would be the x-coordinate of the vertex. For example, this is the curve. Let's say this is -1, this one is 1. So first of all, you need to find the x-coordinate of the vertex by finding out the middle point of -1 and 1. Once you get the x-coordinate, you plug in this x-coordinate in the equation to get the y-coordinate. So these were the steps we used to follow in order to find the vertex. But this was obviously time taking, and here the examiner does not want you to do it this way. He's saying just state the coordinates. It is just a 1 mark part of this entire second part. So you're just supposed to state the coordinates. So what exactly are going to be the coordinates of the vertex? So we have a method here. Let's just discuss it through this one, okay? So if this is your quadratic equation, the coordinates of the vertex are going to be, x would be -a and y would be b, okay? I'll tell you. Whatever number you will have here, you are going to take the negative version of it. For example, if we had x minus a here, so it would have been minus into -a, okay? So in short, in simple, I'll tell you directly, just take the negative version of this. For now, it is plus a. If it was minus a, I would have taken the negative version of minus a, okay? So I'll take the negative version of positive a, that would be negative a, and y is going to be b as it is. So these are going to be the coordinates of the vertex, okay? In our case, what do we have? We have 1 by 2 and we have 1 by 2. So a is 1 by 2. And b is 1 by 2, and the coordinates of the vertex are going to be the negative version of this number. It is -1 by 2, and this one would come as it is. So it is 1 by 2. So this is going to be the answer to the second part, okay? The coordinates of the vertex are going to be -1 by 2 and 1 by 2. Here, you were not supposed to find the coordinates through the long method. You were just supposed to directly write down the values using this form. So how do we do it? Whatever number you have here, for example, let's say you had x -1 by 2. So in that case, this would have been +1 by 2. We just take the negative version of this number right here, okay? And then this one would come as it is, and these two are going to be the x and y coordinates of the vertex. Yes, students, please tell me if you were able to understand this or not.
Yes, please, I understood.
Okay.
Yes.
Okay, and what about you, Ahmed?
Yes, ma'am.
Okay, yes. Do you have a question, Motasim?
Miss, I just want to make sure that the other method using the graph is also correct, but
Yes, yes.
we use this one because The other one is time consuming, right?
Exactly, exactly. You will be using the graphical method for every quadratic equation. This time around, the quadratic equation was given in this form. Okay, every quadratic equation is not given in this form. If you have the quadratic equation in this form, you need not waste your time in making the graph. You can do it directly. But you know, the questions we discussed in the classes were of this type. So for this, you need to do it by graph method. Okay, you can only state the coordinates directly whenever you have this type of scenario. And for this type of a scenario, the examiner would always tell you to state the coordinates. He is just giving you 3 marks for this entire question. So this part only has 1 mark. Okay, so for a 1 mark part, you would not be wasting your time. You're just supposed to state it. But if this was the equation, the examiner would not give you 1 mark. He would obviously give you 3 marks for this. If again the question was about finding the coordinates of the vertex, because then he would know that you will be doing a few more steps and then finding it out, right? So this is the difference in both the cases. Okay.
Okay.
All right. Okay. Great. Okay. So let's talk about another question of another past paper question. All right. Now the question says, the equation of a curve y equals 2x squared plus m into 2x plus 1, where m is a constant, and the equation of a line is y equals x plus 4. Okay, again, this is a curve and this is a line. Okay, we know a few type of cases here. Show that for all values of m, the line intersects the curve at 2 distinct points. Okay. Now, it is one of the 3 cases, but it is other way around. This time around, you have the curve, you have the line. You need to show that for all values of m, in the other parts, we had to find out the value of m. Okay, this is what we used to do. This time around, the examiner is saying, just show that for all values of m, the line intersects the curve at 2 distinct points. So the idea is very simple, I'll tell you. Using this condition, I know that somehow I need to show that that the discriminant b squared minus 4ac would be greater than 0. Okay, if I am able to prove this, then it would mean that the line is intersecting the curve at 2 distinct points. So somehow I need to prove that b squared minus 4ac is greater than 0. In the previous parts, I used to use this condition and find the value of m. This time around, I need to prove that b squared minus 4ac would be greater than 0. So how do we do it? I'll tell you. Okay, this is what I need to prove. So I will not be writing it down initially. Step 1 is going to be, I am going to make my one quadratic equation by equating these y's. So I would get 2x squared plus m into 2x plus 1 equals 6x plus 4. Step 1 was equating y's. Okay. Step 2. I am going to simplify this. So it would become 2x squared plus 2mx plus m minus 6x minus 4 equals 0. 2x squared plus 2mx minus 6x plus m minus 4 equals 0. Okay, now I am going to extract a, b, and c. This is a, the coefficient of x squared. I'll take x common and I would get 2m minus 6. And the constant term is m minus 4 equals 0. Now, a is equal to 2. B is equal to 2m minus 6 and C is equal to m minus 4. Okay, now I need to plug in b squared minus 4ac. Right now, I won't say b squared minus 4ac is greater than 0. No, I need to plug in the values and show that b squared minus 4ac is greater than 0. Okay, so b squared minus 4ac is basically going to be 2m minus 6 squared minus 4 into 2 into m minus 4. Okay, now I am just going to simplify this. So this is going to give me 4m squared. Okay, then I'll do it slowly just so everyone is able to understand. I'll take square of this number, 2m squared, then minus 2 multiplied by 2m multiplied by 6, then plus 6 squared. Okay, this is how I expand any square. All of you would be knowing this. Then minus 4 into 2 into m, 8m, and then plus 4 into 2 into 4. So it would become 8 into 4, that is 32. I need to show that this is greater than 0. I'm just going to simplify this first and then we'll see what is happening at the end. Okay, this would become 4m squared, then minus 4 into 6 would give me 24m minus 8m plus 36 and then plus 32, and it would give me 4m squared minus 32 plus 68. Okay, this is going to be my equation. Okay, now I can take 2 common. This is m. I'll take 2 common and it would become 2m squared. What I can do is I can take 4 common directly. You'll see why I'm doing this. Okay, I'll take 4 common and it would give me m squared minus 8m plus 17. Okay, now I need to apply the completing square method. Why? You will get the answer shortly. Okay, 4. Okay, how is the completing square method? Okay, this has 1, so we are done with the first step already. Then this would come as it is. Then I need to add and subtract the square of half of this number. So half of 8 is 4. So I'll be adding I'll be adding 4 squared and I'll be subtracting 4 squared, and 17 would come directly and this would become 4 is outside, m minus 4 and then minus 4 squared and plus 17. So finally I would get 4 multiplied by m minus 4 squared, and this is going to be positive 1. So when I will multiply 4 with this, it would give me positive 4. Okay, now this is what I am getting. Okay, I will just go back again. I will just follow the context and then I'll tell you. Okay, all right. So here again we had a curve and a line, and this time around the question is similar but it is other way around. You need to prove that for all values of m, the line is going to intersect the curve at 2 distinct points, which means you need to prove that this discriminant is greater than 0. After simplifying everything, first of all, I equated line and curve. I just simplified and I got this quadratic equation, and these are the values of a, b, and c. Okay, I plugged in b, I plugged in a and c, and after simplifying, I got this. Then for some reason, I applied the completing square method, and finally, I got this. Now, what do you think? This is the discriminant basically, right? B squared minus 4ac is basically 4 multiplied by m minus 4 whole squared plus 4. Now it's obvious 4 is a positive number. Square of every number is supposed to be positive. So when I will multiply this 4 with the square, this would give me a positive number. And when I will add this positive number to 4, it is obviously going to be greater than 0. And this is what we had to prove. Okay. So by applying the completing square method, I got this thing. I got this thing that whatever value of m I would have. It could be 0, it could be positive, it could be negative. That does not matter. Square of any number would make it positive. Okay, so m minus 4 whole square was making it positive. So I know that 4 multiplied by a positive number is going to be positive, and when I will add it to positive 4, it would still be positive. And this is how I got that the discriminant b squared minus 4ac would be greater than 0. This is what I had to prove in order to show that the line and the curves would be intersecting at 2 points. Yes. Now tell me if you were able to understand this or not. Honestly speaking, this was not very straightforward. So if you have questions, you can ask me, okay?
Miss,
Yes.
Miss, can we just not do like this? Is equal to 0 and take this 4 to the other side to make it 0 again. So that it's like more simplified.
No, I'll tell
Like
you.
this.
I'll tell you. I get your point. I'll tell you. Basically, if you will say that this thing is equal to 0, okay, then it would basically be that the discriminant is equal to 0. And when the discriminant is equal to 0, the line is intersecting the curve at one point only. You need to show that the discriminant is greater than 0. Okay, only then it would be proof that the line is intersecting the curve at 2 points. So for this, you need to prove a condition, but you don't know what exactly b squared minus 4ac should be equal to. So you're just supposed to plug in the values and do the workings in the direction that would be favorable for you. You need to show that it would be greater than 0. So you would be applying the completing square method, and you know, when you will be applying the completing square method, m would basically come inside a square, and it is very obvious that for all values of m, it is going to be greater than 0, right? If you will equate it to 0, then the basic condition of the question would be changed. Are you getting this now?
Yes, Miss.
Okay.
Okay, Miss, got it.
All
So
right.
it's like after every point, it's like greater than 0, greater than 0, and greater
No,
than 0, like that.
no. You are not supposed to write down greater than 0. You know why? Because you are not told that this is the case. The question says, show that the line intersects the curve at 2 distinct points. So you need to prove that by showing that b squared minus 4ac, that is basically equal to this thing, would be greater than 0. Okay, this greater than 0 is only supposed to be written at the last step, when you can see that this thing would be positive and this thing would be positive and their sum would be positive. Okay, this is what you need to prove. If you are writing it in every step, then there's no point. You need to show that it is greater than 0, and you can only show that after the last step. Okay.
Okay, Miss. Got it.
All right. Okay. And what about Ahmed and Mutasam? Are you okay with this?
Yes, ma'am.
All right. Okay. Yes, Mutasam, any questions? Yes, Mutasam, do you have any questions? Okay, all right. So I hope it's clear with everyone. So these were 2 past paper questions from this chapter. Okay. Still, if you have any questions, because I know this is the very first time we're talking about past paper questions, and the questions we discuss in the classes are not very different. Okay, obviously I need to make sure that those questions are also of the same difficulty level, just so when we look at past paper questions, we are, good with it. So still, if you have anything that is coming to your mind, that why did we just not do greater than 0 at every step, that makes sense. Okay, it is not that straightforward, but by reading the statement again, things would make more sense. Okay, you can ask me, and tomorrow we will be talking about some more past paper questions, and then we will switch to the next chapter. Okay, because this past paper practice is important. We need to talk about a few questions on our own, just so you guys are able to do topicals by yourselves as well. Okay, So that is the idea.
Miss,
Yes.
Miss, can you tell me the paper for the question number 3?
Yes, yes, sure. You can just see it from here. This was the first one.
Yes, Miss.
Okay, 2020 exam, May, June, and paper 1. And the second one was basically this one. October, November exam from the year 2020, and it was paper 1.
Okay, Miss.
Okay, all right, okay. I can also share the marking schemes and the questions with you. You can try doing them on your own once again, and if you're not able to do them, you can ask directly, okay?